In this demonstration, we try to show what's the difference between insulator, like for example the balloon here, and conductor, like metal sphere here. Okay, so here's what I have here is a neutral pith ball. So we use that a way to test whether something is charged or not. Okay, so what I'm going to do is for each of the object, I'm going to charge it at, say, certain called charging site, certain spot on the object. Like for this sphere, I'm going to try to charge it here. First of both objects, we start out with neutral, and I'm going to charge the balloon at certain spot, say this end right here, and we got to test whether this part would be charged. How about the opposite end of that? Okay, that we do not physically come in contact with a charge rod. In the same way with the sphere, for reference, there's a screw right here. I'll probably try to charge near that screw, and then we'll try to see whether the charge, how's the charge behave, the charge that we put on to the sphere. Okay. Let's begin with the balloon. So let's try to show that this balloon is neutral. So I take this balloon and I bring it close here, so you can see that there's no obvious attraction towards the pith ball, and I'm gonna do it at several spot. Okay. In particular, the opposite end, like this one. Okay. So we see that it's not attracting the pith ball. Now I'm going to charge the balloon at this end and see, and then we'll go back and test, see what happened. Okay. So there is the neutral pith ball get attracted to the charge rod. So I'm going to try to touch it here. It may take a lot of charge accumulations before we can see the effect. Okay, let's try. Okay. So I'm gonna bring this front end near a balloon, near the pith ball, and you can see that the pith ball is attracting towards the charging site of the balloon. What about the other end? So let's wait for it to settle down. So I bring it close, and as you can see, there's no obvious attraction. Bring very close. So this part appears to remain neutral. As you can see, it does not attract the pith ball. Let's switch this to the charging end. Oops, see, it's attracted so much that it's accidentally touch. Okay. What about, let me make sure this is neutral again. What about this metal sphere? Would it behave the same way? Okay, so let's first test that the metal sphere is not charged. Actually, there may still be some charge on the fifth ball. Make sure everything is neutral. Okay, I would say that there's no obvious attraction there. I do it at a couple spots. Oops. Okay. This is the, I place this near the potential charging side that we're gonna do. So as you can see, the fifth ball are pretty much just hanging. So the sphere at this point more or less neutral, okay, as we have tested. Now I'm gonna try to charge it. Like I said, I will try to charge it at only near this spot, near the screw right there, and then we will test maybe around several spots to see whether they charge or not. Charge it right here. Okay, I think that maybe time to test it out. So I'm gonna bring the charged sphere, but try to put it, let's test this the farthest spot away from the charging place, which is over here. So I'm gonna test it right here. Okay, maybe I didn't give it enough charge. Okay, let's try to charge it some more. Okay, so let's try to test whether this charged or not. As you can see, as I bring in the charged spheres in, let me make sure this is neutral. the neutral pith ball was attracted towards the charged sphere. Okay, remember we test this around here, which is very far from the charging site. Let's test it, say, somewhat close. The amount of attraction is about the same if you just keep testing it at various places. Maybe some charge leaking. Let me charge this sphere some more. Test it again. Oops. So you can see that the sphere is charged, and even the area that was very far away from the charging site is charged as well. And if we continue to test at various spots, you can see that they all charge. Okay. So what's the difference that we have observed? Okay. So for insulator, like the balloon here, the charge are not free to move. So we put the charge here, then they're just stuck here. This other end remain to be in charge. So charge are not free to move in an insulator. As compared to metal, which is a conductor, we charge is around here, but we test, we see that charge, this area is also charged, and actually by symmetry, the charge get distributed throughout the sphere. So charge are free to move within the conductor.